In our last lesson of solving equations by simplifying first, we practiced or learned and practiced a method called the distributive property. Now, the distributive property, as we know, uses the operation of multiplication. We take a term that's outside of parentheses and we multiply it with each term inside, and the parentheses ultimately disappear, which gives us something as an expression that's part of an equation that looks much more familiar to us. Our new method today is going to be called combining like terms. Now, combining like terms is nothing more than using addition, okay? And more specifically, it's using addition to add terms that are alike or the same on one side of the equation because they're either both variable terms, or adding terms that are alike on the same side of an equation. This is really important because they are both constant terms, okay? So this is really important. The like terms are found on the same side of the equation, because there may be some confusion over us seeing the same term but on different sides of the equation, how we deal with that versus what we're going to do now. So like terms, it's really important. If we think about the equal sign as kind of a dividing line, if anything on one side of the equal sign is alike, either because they're both variable terms or because they're constant terms, then we can add those together and begin to make the equation look a little bit simpler before we move on to solve. And most importantly, we're going to use this method that I like to use for identifying like terms that just makes us use boxes and circles, okay? So I like to put boxes around terms that are alike. I like to put circles around the other types of terms that are alike. And then knowing that combining like terms is addition, I just like to add the pieces that are in the boxes together or add the pieces that are in the circles together. So it's that straightforward. And the only thing we're going to remember is when we put boxes or circles around things is just as we had to get used to yesterday. When I see an operation sign, I want to think of it as being the sign of the term that directly follows it. So when I go to put a box or circle around each of these terms, the sign is going to get included. So let's start with this. And this is for no particular reason, but I generally put boxes around my variable terms. So I know right away in this expression, and by the way, I know it's an expression because there is no equal sign here. So think about this as being what we would see on one side of an equation. So in this case, I have this term of positive 4x. It's the only term with the variable that I see on this side, okay? But what I do see more of one of is a constant term. So I can put a circle around this 5, and if we need to be reminded, we know that 5 is positive, okay? So if it would help you to put a plus sign in front of that before you put the circle, it might be good practice. And I know this 24 is also positive because of the plus sign. So all that I'm going to do from here is combine the terms that I can combine together by adding them. And there's one last thing I am going to do. I should probably make a note of this. Always list variable term first. So as we start to combine, even though there's nothing to combine with the 4x, that's the first thing I'm going to write down. That just makes solving these equations a little bit easier when we look at them. So I'm going to say 4x, that's taken care of. And then I'm going to just simply add, because that's what combining like terms is. Let's see, 5 plus 24, that's 29. That's positive 29. So I'm going to say plus, representing that's a positive outcome, 29. Okay, so I took these two, and I simply added them together, and I got this result right here. And that's it. That's all I need to do. I look to the expression, I find the terms that are alike, I put the boxes and the circles around them, I add those terms together, and I'm good to go. So let's do the next one. So here I have 18x plus 9x minus 11x. I'm going to put, and just like we did with this 5 out front, if I don't want to be confused about what sign it is, I know it's positive, add that invisible plus sign. So positive 18x. And again, being real mindful when you get to the 11x, I'm going to think of it as negative 11x, okay? And this 9, this positive 9, again, being mindful of a sign, is going to get the circle. So if I always list the variable term first, because I have variable terms to add, I'm going to add them. So this is really important to know. This is like saying 18x, because I'm using addition, plus negative 11x. And if I thought about just the coefficients, the numbers that are attached to the variable, I would have a positive 18. Whoops, let's try that again. I would have a positive 18 in my scoreboard. I would have a negative 11 in my scoreboard. I know the 18 would win. I'd subtract and I'd get 7x, okay? And then the 9 being positive, there's nothing more to combine it with. That entire term drops down with the sign, so it becomes plus 9. And once again, that's it. We combined our terms that were variables together. We combined our terms that were constants together, otherwise it dropped the constant term down. And we led with the variable term. We're done. One last example. Notice we have an extra term going on. So I will put a box around my positive 5x. I will put a box around my negative 8x. I will put a circle around my minus 3, my negative 3, and a circle around my negative 5. Okay, so we're using calculators to assist us, so we can just simply do 5 plus negative 8, and we should discover that gives us negative 3x. And I can do negative 3 plus negative 5, and because I get something negative, it's going to show up as a subtraction sign. This is what's going to be a little bit trickier to us, so minus 8. But once again, we're done, okay? We took our variable terms, we combined them together. We took our constant terms, we combined them together, and we have a much simpler expression, thus the reason why we call this simplifying. We have a much simpler expression than what we started. So this, just like with the variable term, is allowing us to take equations like we see below and hopefully get them to look easier and essentially turn them into a two-step equation that will get us back into where we're comfortable solving equations. And once again, I'm going to walk you through what I think to be the toughest of these three. This last one, which looks very similar to what we simplified up above. And I'm going to leave the other two for you, which look very similar to the expressions that are right up above that we simplified, okay? So let's start with, as always, adding our invisible positive sign into that lead term if it's not something that's negative otherwise. Put a box around that 2x. Put a box around that negative 4x. Go back and circle the minus 9 and the minus 1. And now get to work on combining your like terms with the variable terms for us. So I have a negative 2 plus negative 4 on the calculator gives us negative 2x. I have negative 9 plus negative 1. That gives me negative, so minus 10. And then I have equals negative 12. Notice from here, I have a two-step equation with the variable and constant is equal to a constant. And very specifically, I'm going to add or subtract a constant term. These are the only types of two-step equations we're going to see. So step 2, if it says minus 10, I'll add 10. So I get negative 2x equals negative 2. And then from here, quickly, step 3. So I did step 1 with my simplifying, my combining like terms. Step 2, I did my isolating. Step 3, I'm going to use an inverse operation, divide by this negative 2 to undo the fact that x is being multiplied. And I get a final solution of x equals 1. So that's my third step. So one last time, we go through this process just similar to yesterday, but using a different method of simplifying called combining like terms. I use this box and circle method. I use this box and circle method to combine the variable terms together, to combine the constant terms together, and that will lead me to a two-step equation that I can isolate the variable and solve for the variable. So these next two equations, look back at the expressions up above as needed to simplify the expressions on the left side of the equal sign in both, and to then be able to solve the resulting two-step equation. And when we meet in class, we will discuss and practice more.